Your flipped video today is on completing the square. The student will be able to use the method of completing the square. That comes straight from our TEKS, straight from the things that you have to learn this year. Okay, so I'm going to show you two really simple ways to do this, and we are doing very simple problems in this example. We will get into problems that are a little bit more difficult tomorrow. Okay, but I want to show you an area model first of all. Okay, this represents x squared. These represent x. Okay, so if I gave you a problem something like x squared plus 6x, it would look like this. Or we would make it look like this. We wouldn't want to line them all up, and you'll see why in a second. Okay? And I said, I need you to complete this square. Physically complete this square. How many pieces are we going to need to add at the bottom to complete this square? Well, I need to add those three. And I need to add these three. And I need to add, whoops, 1, 2, 3 more. So how many pieces did I have to add in this corner to complete this square? 1, 2, 3, 4, 5, 6, 7, 8, 9. Like that. Okay? What if I gave you a problem like x squared plus 4x? That's just how it starts. Well, there's the x squared. There's 2 of the x's, and there's 2 of the x's. So that's 4x. So how many would I have to add in this corner to complete this square? 1, 2, 3, 4. Okay? Hopefully you would see we would have to add 4. I'm having to add a constant to complete the square. Okay? So why am I putting 2 on this side and 2 on this side? Or why did I put 3 on this side and 3 on this side? Well, because if this is x and this is 3, to be a square, I need this to be x and this to be 3. Okay, does that make sense? So if I give you a problem like x squared plus 16x, well, I don't have 16 of these, so we need to be able to visualize this. Okay? I would put 8 on this side and 8 on this side. Right? 8 of these things right here and 8 of these things right here. So how many would have to go in this bottom corner? If this is 8 long and this is 8 long, I hope you see that that would be 64 to complete the square. So algebraically, algebra tiles, we can do that pretty easy. Okay, just put in as many little blocks down there as it takes to fill it in the square. Algebraically, I hope that you see that in order to fill in this last blank, in order to complete the square, I need to take the x value, the multiplier on the x. If I divide it in half, like I did here, put half here and half here, and then square it. What is 6 divided by 2? Well, that's 3. 3 squared is 9. 4 divided by 2 is 2. 2 squared is 4. 16 divided by 2 is 8. 8 squared is 64. Okay? X squared plus 10x. What do you think? I could put 5 here and 5 here. That would leave me a square that's a 5 by 5, which would leave me 25 to add to complete my square. Okay, so let me throw you a curveball. What about x squared minus 6x? So these would be red because it's minus 6x. Negative 3 and negative 3. Guys, what is negative 3 times negative 3? That's still 9. Okay? Arithmetically, algebraically, if I took this number and divided it by 2, that would be negative 3. Negative 3 squared is still a positive 9. Okay? Negative times a negative, negative times a negative to give me 9. So will I ever subtract any number right here to complete the square? I hope that you would see that the answer is no. So what about x squared minus 8x? What's it going to be? Divided by 2, square it. 16. x squared minus 12x divided by 2, square it, plus 36. Okay? In your comment section or your question section, either one, I would like you to create one of these and tell me how many it would take to complete the square. We will talk more about numbers tomorrow like this that are not even numbers. We'll talk more about what to do if there's a multiplier in the front. Okay? We are going to spend 2 days on this topic, so come prepared to learn. I hope you have a great day, and I will see you tomorrow.